6. Inequalities in two variables. At the end of this, you'll be able to graph an absolute value inequality on a coordinate plane. You'll be able to write an absolute value inequality from a given graph or coordinate plane. And you'll be able to graph a quadratic inequality and graph a system of quadratic, absolute value, linear inequalities. Let's get started. First, graphing absolute value inequalities. Recall that an absolute value function is a V, as in victory or Virginia, shaped graph. You can create a table of values, plot the points, and connect the points to form the V. Or, better yet, you can recall graph transformations. You can also see the table function on your calculator to help you with the points in the graphs. Let's warm up by graphing some of these. We're just doing equations, not inequalities right now. So this first one is y equals absolute value of x. Well, that's the parent function. And we know that the absolute value of 0 is 0, the absolute value of negative 2 is 2, the absolute value of negative 4 is 4, of 2 is 2, of 4 is 4. And we know that it is a V with the center point, the point of inflection, at the origin. Now, when we come over here, we've got a transformation. A multiplication on the outside says that I will vertically stretch it by 3 and plus 4. Remember, this is the same thing as x minus negative 4. Well, that tells me that I am going left 4. So I'm going to move my vertex to the left 4. Then, instead of going right 1, up 1, I'm going to go right 1, up 3. Graph transformations. So here it is. I moved the vertex to the left 4, then I went right 1, up 3, right 2, up 6, and so on. I simply I tripled whatever my right and left were. Whatever I do on the right, I do on the left. Again, these are just the transformations we've been talking about before. I have the points listed here, but better than that, note the transformations and then graph the function. Pause the video and then come back. Are you back? Let's take a look. Here, this is right 3, and when you subtract on the outside, you're going up and down, so that's down 2. I'm simply going to move the vertex to the right 3 and down 2. Then I'm going to use the parent pattern, 1, 1, 2, 2, and I could keep going 3, 3, 4, 4. Here it is. Right 3, down 2, right 1, up 1, right 2, up 2, and so on. This next one over here, I'm going to reflect over the x-axis. I'm going to go to the right 2, and here is up 4. Hey, remember, on the inside affects left, right. On the outside is your up and down. So first thing you're going to do is move your vertex to the right 2, go up 4. Then, when you do your pattern, which is 1, 1, 2, 2, instead of going up, you're going to go down because of the reflection. So, right 2, up 4, I go right 1, down 1, right 2, down 2, etc. Great! You've got these down pat. Now, when we talk about inequalities, we want to talk about the less than, greater than. Instead of equals, we have a greater than or equal to, less than or equal to. We can kind of make a chart here. If y is greater than or equal to, we will be shading above the v. If it's less than or equal to, we will shade below the v. If it's greater than or less than, we will use dashed lines to create the v. If there's an equality in it, greater than or equal to, less than or equal to, we'll use a solid line to create the v. This is really no different than when you've graphed lines or linear inequalities before. So, if we take a look at these, notice that I have the, oops, there we go. Okay, I have the inequalities. And over here, I've also noted that I have to get y by itself first. Okay, so don't forget over here, you have to isolate y. Other than that, we're going to note our transformations. This is a right 4. This is up 5. So, right 4 and up 5. Now, based on the previous slide, what kind of line will I have? Dashed or solid? If you said solid, you're right. Y is less than, so I'm going to shade. Will I be shading above or below? Think about it like this. If I give you any given y, where are all the y's that are less than that one? They're below. So I'm going to shade below. Bigger y's are above, smaller y's are below. Now that I have it, I simply graph it. I go right 4, up 5, and I put my point. I go right 1, up 1, right 2, up 2. Whatever I do on the right, I do on the left. Because it's equals, I made the V solid, and because the Y is less than, I shaded everything below. Okay, the next one over here, notice that I had to get Y by itself, and here I had to pay attention. I divided everything through by negative, so I had to reverse the inequality. Now notice that I just put the negative times the whole quantity in absolute value. You do not distribute into the absolute value. That's a no-no. All right, so once I have this, I should notice that I have a reflection over the x, left 1, up 3. Boom. What kind of a line will I draw my V with? Well, it's just less than. There's no equals, so it should be dashed. This one is also less than, so it will be below. Once I write all this down, graphing, I just have to follow my own directions. My own directions said to go left 1, up 3, reflect over the x-axis, which means the V is upside down, and make it with a dashed line. So right 1, down 1, right 1, down 1, right 2, down 2. Whatever I do on the right, I do on the left, and I draw my V-shaped graph. And then, of course, I have to do the shading. How do you know when you shade? When you have an inequality. If it's an equation, only the points on the line or on the V, on whatever graph it is, are part of the solution. If it's an inequality, meaning greater than or less than, then you have an infinite number of points. You've got all the points either above or below the boundary, and it may or may not include the boundary, depending if there's an equals. Now, try these two, and notice over here in the purple one, I even said you had to solve for y. Pause the video, and then come right back. Okay, you're back. I'm assuming you paused the video. Did you get these as your transformations? Left 2, down 3, reflect over the x-axis. No equals, so it's dashed. Y is greater than, shaded above. Bada bing, bada boom, here it is. Left 2, down 3. Right 1, down 1, right 2, down 2, shading above. Okay, what about on the right-hand side? Well, I got to solve for y first. So I'm going to add 6 and then divide by 2. Now, remember that I cannot divide into or distribute the division through the absolute value. The absolute value is like a black box. So dividing by 2 is the same thing as multiplying by a half. That's where I get the -1/2. Transformations, reflect over the x-axis, vertical compression by a half, right 5, down 3. Equals, so it's solid, less than, it's below. Now, here's the graph. Okay. Notice that when you graph, you go all the way to the edges of the graph. And then when you shade that entire area. Okay, I should never see like a little thing like this and then somebody shading like this, because notice, there's an error out here if the graph went like this. Don't get sloppy. I have rulers if you need to use them in the classroom. At home, you can certainly find a straight edge. You can even use an index card. Okay, Now quadratic inequalities. Dashed less, oops, so let's do this. Less than or greater than. Oops, put it in the wrong place, didn't I? Dashed less than or greater than. Solid less than or equal to, greater than or equal to. Shade up, greater than or equal to. Shade down, y is less than or equal to. For a system of inequalities, any point that lies within the shaded area or on a solid boundary line of that area is the solution. Then the, oops, sorry, this should be overlapping because this is a system. The overlapping shaded area or on a solid boundary line of that area is a solution. Let's see what we're talking about. Well, first we have these two different inequalities. We're just going to graph basic inequalities first. Now this first one, notice that a is negative, so it's reflected over the x-axis. I need to find my vertex. Well, x is equal to negative b, that's 2, over 2a. That's going to be 1. How do I find the y value? I plug 1 into the x value. So y is equal to negative 1 quantity squared plus 2 times 1 plus 1. This is negative 1 plus 2 plus 1, or just 2. So at 1, 2, I have a point. Now I know a is the same whether it's in the standard or in the vertex form. So this tells me that I'm upside down. My pattern is 1, 1, 2, 4. So right 1, down 1. Right 2, down 4. Whatever I do on the right, I have to do on the left. And then it's going to be a dashed curve. Oops, if I can get my pen to write here. It's going to be dashed. And then because y is greater than, I'm going to shade above. So let's go get a crayon. And let's shade all of this area above. Okay. Notice I'm not trying to color everything in. I'm just indicating it's everything above. All right? That's that one. If we come over here, this is the nicer kind. This is the vertex form. This says I go right 2, down 3, and a vertical stretch of 2. Right 2, down 3. Vertical stretch of 2. My pattern's 1, 1, 2, 4. I'm going to multiply the up by 2. So that means I'm going to go right 1, up 2, right 2, up 8. Whatever I do on the right, I have to do on the left. Because it's got equals, I'm going to do a solid curve. And trust me, this is so much easier with your pencil than on a computer screen. And then I need to shade it. So how am I going to shade this? Y is less than or equal to. So I'm shading everything below this U-shaped curve. And notice my curve is kind of wonky. It's not the best. Okay, part of that's just trying to draw with this pen on the surface. That's okay. I've given you specific points so you know where I'm trying to connect my smooth curve. I'm not going to be grading you on your ability to draw a smooth curve. I am going to grade you on your ability to find 5 specific points. Now, if I want to graph a system of solutions, that means I'm going to look for the overlapping area. So, if I look at this first one, this is a quadratic. This one says that I'm going to go right 3 and down 6. Then I have a vertical compression by half. So right 1, up a half. Right 2, just up 2. If I go right 3, I'm going to go up 1, 2, 3, 4 and a half. Whatever I do on the right, I have to do on the left. And because it's got the equals in it, it's going to be a solid curve. I want to try to make it go the whole way of the graph. Now, y is greater than or equal to. So this means I'm going to shade above, but I'm just going to put a little bit of shading there. Okay. Actually, we can use our crayon. So y is greater than or equal to is all shaded in here. This next one happens to be a line. It's not a quadratic, it's just a linear. It has a y-intercept of -4 and a slope of 1/2. Rise 1, run 2. Don't forget how to draw simple things just because we're going on to more complex. It's going to be a dashed line. Okay, I'm going to put my arrowheads on. And then y is greater than. So where will I shade? I'm going to shade above. So I'm going to shade up here. Now, where is the overlapping region? The overlapping region is here. So this that's in the gold, that is my solution. All the points that are solutions are anything on this part of the green line that's above the dashed red, or the green curve that's above the dashed red line, and the solid green here, and anything in this yellow overlapping shaded area. Let's look at this next one. If you want to, you can always pause the video first, try it, and then come back. Are you back? All right. This first one here is a little bit tricky. It's -x times x plus 4. Ooh, that's a quadratic. Okay. Now I do know that it has x-intercepts at 0, because if we put 0 in there, that's good, and at -4. What I don't know is exactly where the vertex is. So I do know, however, that it's halfway between these two, which means it's at -2. So if I put -2 in, I get -2 times -2 plus 4. This is going to be 2 times 2, which is equal to 4. So I come here, and at 2, I come all the way up here and find my vertex. A couple of different ways to do it. You could also, another option, in addition to that one, because I run out of room here, you could get -x squared minus 4x. You now have x is equal to -b over 2 times a. So that's 4 over -2, which is -2. Boom, our x. Then you can plug -2 in here or into here, and you would get 4. Okay, so lots of ways to solve the same problem. Now, once I have that, I do know that if I get -x minus 4x, I know I'm going upside down, and I know there's no stretch or compress. So write 1 down 1, write 2 down 4. Look, that matches. I could also go write 3 and realize that I'm going to be down here at 9. It's going to be a dashed curve. Why is it dashed? Do you know? If you said because there's no equals in the inequality, you are correct. Now I need to shade. Y is less than. Where are the y's less? The y's are less when I am below the curve. So here's my shading area. Oops, didn't change the color, so we'll just leave that as yellow. The next one is an absolute value. This is a V-shaped curve. This one says I went left 2, down 3, vertical stretch 2. Left 2, down 3. There's my vertex, vertical stretch of 2. Since my pattern's 1, 1, 2, 2, I go right 1, up 2, right 2, up 4. What I do on the right, I'm going to do on the left. It's got an equals, so this V is going to be a solid V. And then I need to shade it because it's an inequality, and I'm shading everything above. Now notice if I shade everything above, what's going to wind up being double shaded is just all this stuff that's under the curve, okay, under the curve and above the V. So this would be my overlapping shaded region. Okay. Answers, or when you finish shading, you want the overlapping shaded regions. Okay? Excellent. Let's move on. If we want to graph this inequality, well, x-intercepts. I set each factor to 0. So here this would be x is -2 and x is 6. So I can get those very quickly. I'll just move these guys down here. So I've got -2 and I've got 6. My axis of symmetry, it's halfway between these two. So I can do -2 plus 6 is 4 divided by 2 is 2, or I could count in. There's lots of things that I could do. Either way, I'm going to get that the axis of symmetry is 2. I know it's upside down, so I know my vertex is going to be up here somewhere. How do I know it's upside down? Because A is negative and A is always the same no matter which form I've got. How do I find the vertex? Well, I'm going to plug 2 back into this equation. So I have -1/2 times 2 plus 2 times 2 minus 6. This is -1/2 times 4 times -4. -1/2 times 4 is -2 times -4, times -4 is +8. So 2, 8, there's my point. That's my vertex. Now y-intercept, I can plug 0 in for x and 0 in here. I could also just know that it's a vertical compression. So I'm going to go right 1, down 1/2, right 2, down 2. Same thing here. And look, I found that my y-intercept is 6. How else could I get that it's 6? I could do 0 is equal to -1/2 x plus 2 times x minus 6. I'm going to run out of room there, and I could solve for x. Okay? Either way is fine. When I graph this, it's going to be dashed because there's no equals. Sometimes I kind of make that curve up there, up here solid, just because it's hard to dash it through. But then I'm going to shade below. Why am I shading below? Because y is less than. So here's everything below this curve. Okay? Now, here you're supposed to write the inequalities. My. We have to write them. Use the vertex form. For this one right here, I'm going to do this one in blue. Well, I went right 2, down 3. So x minus 2, quantity squared minus 3. Then I'm going to start here and go right 1, up 1. Well, I'm on the curve, so there's no stretch or compress. So I have the y. It's a solid line, so I know I have equals in there. And I shaded above, so y is greater than or equal to. Great. Now, let's try this one. I'm going to do this one in green. This one, I went to the right 4, so I have x minus 4, quantity squared. But this, I brought the vertex up to 4, so I have to add 4. Now I check for stretch or compress. Right 1, down 1. Nope, it's on there, but it is reflected, so it's a negative. Now I have my y here. I'm going to do less than because I'm shaded below, and there's no equals because it's dashed. I've just written both inequalities. This is the system of inequalities that defines A. Now B, Let's make sure that we don't screw B up. B is easy. One of them is really easy. It's a line. You've been doing lines since Algebra 1. How do you do a line? Remember, y mx plus b. Since this is below, it's going to be less than. It's solid, equal to. So I have y less than or equal to. My y-intercept, b value is 6. I have the x, my slope. Well, I have to run along here until I find another spot. And I double check it here. This has a rise of 2 and a run of 3. A rise of 2 and a run of 3. So my slope is 2/3. That was easy. What about the quadratic? Well, it went to the left 3. So I've got my y, and then left 3 is x plus 3. I got to square that. I go right 1, up 1, still on it, so there's no stretch or compress. And I didn't move the vertex up or down, so it stays there. So I'm done with that. I did shade above, so I know it's greater than. Since it's dashed, there's no equals. Voila! Done. You've written the system of inequalities for B. What are we up to now? Oh, example 4. So, example 4, this says a solution must satisfy all inequalities on the graph. It must lie in the overlapping shaded region or on a solid line bordering that region. Determine if the ordered pair is a solution. So I've got several of them. And again, you could, the one way you do it, there's two different problems here. There's A and B. If you're given the inequalities in equation or inequality form, okay, as expressions, you can simply plug in the value 1, 1. Okay, so I can plug in 1, 1 to the first one. 1 is greater than -3. Yay, that works. I plug 1, 1 into the bottom one. 1 is less than or equal to 3. That works. So this is a solution. If I plug in -1, 1, 1 is greater than -3. That works. 1 is less than -1. That's not true. So this is not a solution. If you're given the expressions, you can simply substitute in and check. What about for this next one over here where you're given the graph? That's super easy. Here I'm going to go to 3, -2. Boom. Well, it satisfies one, but not both. So it's not a solution to the system. 1, -3, that is not a solution to either. It's landing on the dashed curve. It's a double whammy X. It doesn't satisfy either. 2, 3. That's a happy one. Okay? It's in the overlapping shaded region, so it is a solution to the system. 1, 6, notice here's 5, here's 6. That too is a solution. Why? It is on the solid line that is part of the boundary of the overlapping shaded region. So here you're being asked, is a particular point a solution? In summary, to graph an inequality in two variables, rewrite the inequality in terms of y. Use transformations to graph the absolute value or quadratic. Use a solid line or curve if the inequality is less than or equal to or greater than or equal to. Draw a dashed line or curve if the inequality does not contain equals, if it's just less than or greater than. Then, big Y's, y is greater than or equal to or greater than, shade up. Shade below if the inequality is y less than or equal to or y less than. That's absolute value inequalities systems in two variables.